Hey everybody, this is Larry. This is me doing week 1 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. I'm very excited to see a problem that I haven't done yet. We have 1940, longest common subsequences between sorted array. Alright, let's see. Given an array of integer arrays where they're sorted in strictly increasing, okay, so we have arrays in strictly increasing order, return an integer array representing the longest common subsequence between orders arrays. So it has to be in all 3 arrays. Is that it? I mean, that seems pretty straightforward. I think the idea is, and because they're strictly increasing, which I guess just makes the language easier. I don't think that, like if it's monotonically increasing, does that change the answer? I don't think so. At least not. No, I don't think so. It's just like an extra if statement, I think. But in any case, yeah, I mean, I think this is essentially the merge sort idea. There are a couple of ideas that you can play with, right? Because because the longest common subsequence is a really silly phrase for this particular problem, in the sense that it is just all the common elements, right? Because you want, in a greedy kind of way, if there's an item that is in all of them, why wouldn't you just take it? And so as a result, it's just in all of them. And you can do it in a naive way with a for loop, and given that n is 100, you probably could get away with it. N is 100 and each array only has 100 elements. But I think the canonical way of doing this is actually with there are probably two major canonical ways of doing it. One is with the same idea with merge sort, and then the other idea that I would have is with a heap, right? Sort of a heap, kind of just keep on removing the smallest element. And I think they're both fine depending on how you want to do it. I think the merge sort is actually probably yeah, I want to say the merge sort will probably end up being more efficient. Yeah, the merge sort will end up being more efficient just because the common items will self-filter, so then later merge stages will be smaller in practice, maybe. I mean, of course, I'm saying this agnostic to the constraints, and the constraints are really small, like I said, so you can pretty much do anything and be right? Because you have, I mean, each element is only up to 100, so you could even put everything in a set or something, or not a set, but a frequency table, and that'll be right too, right? So so there are a lot of things you can do on this one, and if I was in a contest, maybe I would just put everything in a frequency table, because then I can probably do this in like 5 lines of code, right? But yeah, should I do it that way? I don't know. It's all the ways are kind of really funky. But yeah, and I want to also point out another thing with merge sort is that maybe I'm wrong on this now that I think about it. The idea with merge sort is that the idea with merge sort is actually that how to say it? The idea with merge sort is that when you merge, you have 2 arrays of element of size L. When you merge, it's the size of 2 times L. So then the merges, so you want the merges to be balanced in that way, so that it merges in a very balanced way. But this is actually not the case for this problem. So you don't actually even have to do it what I would say tournament style merge sort. You can just do it by one, right? Meaning that okay, like let me draw up some. I'm just kind of, I mean, this is not a hard problem, but I'm just like having some ideas and playing around within my head, and I think for now I find it a little bit interesting, so that's why I'm kind of going on a little bit. Feel free to fast forward if this is not. But yeah, what I'm saying about tournament is that, you know, you have a merge sort idea of like, okay, you have 2 arrays and you merge them, and then you merge them, and this is a merge sort, right? Like a regular tournament, but you can actually also do something like just be lazy, right? You could just, you could actually merge, you know, these 2, and then merge this one and this one, this one and this one, this one, this one. And the reason is because the merge actually reduces the number of elements, not add to them. right? So that actually makes the computation even more cheap, if you will. So I'm going to do it this way. And actually, you can even do the merge sort in this way, but it's a little bit funky in the sense that you don't even need to, really. You can probably do something really lazy and still be right, which is that my watch is being really weird because I think I dropped it a little bit. But yeah, but for example, you have maybe f is equal to collections.counter arrays of 0, right? And then now for I in range of n, where n is the length of arrays, and maybe one of n, right? Then now f, we end it with collections dot. It doesn't have to be. Actually, what am I doing? It doesn't have to be a counter. Why am I doing a counter? It could just be set, right? Set of array sub I, and then at the end we just return f dot, well, just f list or sorted, I suppose. Right, and there you go. I mean, because we have to sort at the end, it makes it n log n at the very end. But that's just me being lazy on the typing. Because you can, but that's basically the idea, right? You just take one and you keep on merging it one at a time, and it just keeps on getting smaller, so it keeps on getting faster, the way that you think about it. Yeah, and but we have to kind of to retain the idea that it's a subsequence. We have to keep it in order, but not a huge deal, because it can only have 100, at most 100 elements, and you can also do a linear sort if you want, but I don't know. That kind of, yeah. I mean, it's not that interesting. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. I'm going to do a bonus one after this because it is Friday, and why not? And it's the first day of the month, kind of. It's technically May 31st here, but anyway, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.